Hello everyone, welcome to the video solution of May 2025 Unit 1. This is the most recent paper and understanding each and every single concept carefully will definitely help you ensure a decent grade. So let's get to work. Let's look at the very first question. The first question says, a cube of volume V is placed in a liquid of density rho. The cube displaces a weight W of the liquid. Which of the following gives the magnitude of the upthrust? So all you have to do for this question is literally just recall the definition of upthrust. Upthrust is the weight of fluid displaced. And guess what? They have tried to complicate things, but you don't lay your feet in the trap. So upthrust is basically the weight of fluid displaced, and they have directly given you the weight of fluid displaced, that is W. So answer should be W, meaning D. Question 2 says, a seesaw is a uniform beam that balances on a support. The beam can rotate around the top of the support. Two children of equal weight sit on a seesaw at equal distances from the support. Right, so if they have equal weight and they're sitting at equal distances from the pivot, the body has to be in equilibrium, right? And when a body is in equilibrium, the resultant force is zero. Also, the resultant moment is also zero, right? So at times, they often ask you to draw on the diagram the forces acting on the bodies in concern, maybe on the seesaw, right? So this person is exerting a push downward, this person exerting another push. Always remember, weight of a body acts on the body itself. So this body is not exerting his weight on the seesaw. This person is exerting his push on the seesaw, right? So there are two downward forces, and to keep the seesaw in equilibrium, there has to be an upward force from here upward, and the length should be equal to twice the size of either one, because these two added up gives you the upward force. The two downward forces added up gives you the upward force, right? So the forces are balanced and the moment is also balanced because the body is in equilibrium. So answer should be A. Question 3 says, the diagram shows a ball of mass m moving at speed v along a horizontal table. The ball leaves the table. The time taken between the ball leaving the table and landing on the floor is t. Second ball of mass twice m moves at speed twice v along the table. Find which of the following gives the time taken between the second ball leaving the table and landing on the floor. So for this specific question, this is a lovely question. You have to recall the concept of independence of horizontal and vertical motion. So both the balls are falling from the same height, right? They have the same height, everybody, right? And even though the masses are different, even though the horizontal speeds are different, since they're being launched horizontally, both of them has an initial vertical velocity of zero, right? So recall the equation, S equals ut plus half at squared. Both of them are launched horizontally, meaning vertical in the vertical direction. U is zero, meaning ut is also zero. So the equation gets reduced to S equals half at squared, right? Since so for both the balls, since they fall the same vertical height s, they have the same vertical acceleration. Guess what? It will take the same time for both the balls to land, even if they have different masses and they have different horizontal velocities. So answer should be T. For question 4, it says the forces acting on a person sitting on a chair are weight and normal contact force. Which of the following gives a reason why these forces do not form Newton's third law pair forces? So let's first recall the requirements for two forces to be Newton's third law pair forces. Forces must be equal in magnitude, opposite in direction, same line of action, must act on two different bodies, and must be of the same type. So weight and reaction are actually equal in magnitude, opposite in direction, same line of action. But if you match 3 out of 5, that doesn't make it Newton's third law pair forces. You have to match 5 out of 5 requirements, right? So what are the two that it does not satisfy? The two forces are acting on the same body, but for Newton's third law pair forces, the forces must act on two different bodies. And the other requirement is the forces must be of the same type. Weight is a non-contact force, gravitational force, whereas R is actually the other name for reaction is normal contact force. So it is a contact force. The bodies need to be in contact. And just for revision, weight and reaction forms Newton's first law pair forces. Always remember, when equal and opposite forces act on two different bodies, it's called Newton's third law pair forces, and when equal and opposite forces act on the same body, it's Newton's first law pair forces. So weight and reaction are actually first law pair forces, not third law pair forces. 5 is also a very important question. It's associated with vectors, of course. A wire is used to hang a picture from a hook on a wall. The wire exerts forces T1 and T2 on the picture. The picture has weight W as shown. Okay, which of the following describes the relationship between the forces when the picture is hanging on the wall? Right, so when the picture is hanging on the wall, it's not in movement, right? It's not in motion. It is at rest. So what's the other term for a body at rest? It is in equilibrium, right? And when a body is in equilibrium, all the forces on it are balanced, meaning the resultant force is zero. So what you can do with this is form a vector diagram, right? So I'll keep, and the requirement for drawing a vector diagram is always from tip to tail. So what I can do is I can keep T1 as it is. T1 is in this direction, and at the tail of T1 I put T2, because always remember vectors must be arranged tip to tail. So this is P2, and W comes in this direction. Always you have to ensure the directions as well. And when you look at the vector diagram, it shows that it forms a complete loop, meaning if you add up all these forces, of course it has to be the vector sum. So the vector sum of all these forces should be zero, as in the resultant force is zero. And you know the symbol for vector. This is the symbol for vector, right? So the vector sum of all of these forces should be zero. So the answer should be addition of all three forces zero. Answer should be E. Because when you add up all these forces, the vector sum of all of this is zero. 6 is somewhat of an easy question. An object has a constant non-zero acceleration. Which of the following displacement time graphs, okay, would represent the motion of the object? Of course, the answer is B, because you see continuously the gradient is changing, and the gradient of displacement time graphs gives you velocity. Since the gradient is changing, velocity is also changing, and change in velocity, the other name for change in velocity is acceleration. That's why my answer is B. So question 7 says the forces acting on a helicopter are shown. The helicopter is represented by the dot. Which of the following expressions gives the magnitude of the resultant force? Right. So you can see these two forces are collinear, right? These two forces are collinear, and you can actually um, find the resultant of these two forces because they're on the same line. So the resultant of the vertical forces would be, let me draw it here. This, of course, would be downward because this is the greater force. This is 15,000 minus 14,500. So when you do this, this is the resultant of these two forces. And if you want to arrange a vector diagram using this as well, the rule stays the same. Vectors must be arranged tip to tail. So at the tip of this vector goes the tail of 200. So this is 200, everybody. And guess what? Since this time the body is not in equilibrium, it will not form a complete loop. So the resultant should be in the opposite direction. These two makes tip to tail, and the resultant is in the opposite direction. But it still forms a right angle triangle with this side as the hypotenuse. Right? So the resultant squared is this value squared, as in one of the sides squared, plus the other side squared. Right? So the resultant should be root over the whole thing. So resultant force, let's call that F, right? So F squared should be equal to 15,000 minus 14,500 squared plus 200 squared according to Pythagoras. So F should be root over the whole thing, right? And this matches D. So my answer should be D. 8 is a relatively easy question. The question says, a box of weight W slides down a ramp. The ramp is an angle theta to the horizontal. The frictional force F acts on the box as shown. Which of the following is correct when the box moves at a constant speed? So see, I think you already know this concept from your mechanics M1. If this angle is theta, this would also be theta, right? So this weight will have two components. One component would be perpendicular to the ramp, the other one would be parallel to the ramp, right? So since this component doesn't have the angle, so this is W sine theta. And the other information that's given in the question is constant speed, right? So if something is falling with a constant speed or moving with a constant speed, the resultant force is zero, meaning the forces are balanced. So the downward force has to be equal to the upward force. So F should be equal to W sine theta. The only option that matches this concept is C, F equals to W sine theta. Now let's look at 9. The driver of a car applies the brakes. The frictional force F between the tires and the road is constant. The average power dissipated by F is 50 kilowatt. All right. The car moves a distance of 13 meters in a time of 2.3 seconds before coming to rest. Fine. Which of the following expressions gives F in newtons? So it's a very, very, very basic work and energy question, right? So power is the rate of transfer of energy or rate of work done, right? So this F is doing the work. This is the frictional force that is doing the work for bringing the car to rest, right? So rate of work done is equal to power. So you break this down. Work done should be force into displacement by time equals power. And the question asks you to find out F. So F should be power times T goes on the other side divided by S. Of course, you have to convert power from kilowatt to watt. So 50 kilowatt is 50 times 10 to the power 3. The time is 2.3 seconds divided by the displacement is 13 meter. So answer should be A. Question 10 says, a toy train of mass 3m is moving with speed v. A toy train of mass m is moving with speed twice v in the opposite direction as shown. Fine. The train and the truck collide and move off together. So this is a very important piece of information, that they move off together. Okay. Which of the following expressions gives the new speed of the train and the truck? Fine. So let's first find out the total momentum before collision, right? So total momentum before collision would be 3 mv minus twice mv, because it's moving in the opposite direction. And this is just a convention, no rule. That actually, this is a convention from my side. I take I generally take the right side to be positive and left side to be negative, right? So that's exactly what I've done here. So the total momentum before collision would be twice mv minus twice mv gives you just mv. And we all know total momentum before collision is always equal to total momentum after collision, right? So total momentum after collision is also equal to mv, right? But let's now focus on the move off together part. When something moves off together, right? When something moves off together, what you have to do is um, add up their masses, right? So when you add up the masses, now when you add up the masses, thrice m plus m, since they're moving off together, is 4m. 4m, let's call that vf, final velocity, right? With which they move off together, equals mv. So this m cancels out. So the final velocity is the velocity v divided by 4. So the only option that matches this is A. Is 0.31 meter per second squared. Calculate the boat, weight of the boat, sorry. So you have resultant force, you have acceleration. So the very first equation that should pop up in your head right away is F equals ma. And I know the value of F, which is 4,800, equals m times A is also given, 0.31. And in 3SF, the value of the mass is 15500 kg. But the question asked for the weight, and you know the age-old equation, W equals mg. So all you do is just multiply this value with 9 point, as in 15500 times 9.81. And the value is the full value in the calculator I'm seeing right now is 152,055. So you can round it off to 2SF. That becomes 150,000. 150,000 Newton. This was one of the easiest questions. Very important concept that I have to tell you all is, so let's say for the weight, you had to find out the mass, right? So this was an interim calculation. You can only round off your final answer to two significant figures, and the interim ones has to be kept in 3SF. So see, I did not round it off to 2SF, the value of m I mean, right? So since this was an intermediate calculation, I had to keep it at 3SF. Always remember, the final value can be given in 2SF, but the interim ones has to be calculated to 3SF at least. Question 12 says, a person rides a bicycle along the path shown. Right, it's a carved path. At the end of the path, the magnitude of the displacement from the start is less than the distance traveled by the person, of course. So displacement is definitely less than the distance traveled, right? So describe why the displacement is less than the distance traveled by the person. Always remember, displacement is the shortest distance between 2 points, and the shortest distance between 2 points is always a straight line. So if you draw a straight line from start to the end, you'll see that this length is much shorter than the entire path. right, that it had traveled. So the 2 points should be displacement is a straight line from start to the end, and distance whereas distance is the length of the path. The next part B of the question says the velocity time graph for the part of the bicycle ride is shown. Determine the maximum acceleration of the person on the bike. So I want you all to focus on this term, maximum acceleration. And what graph do you have? You have a velocity time graph. You all know that the gradient of the velocity time graph gives the acceleration. And since they asked for the maximum acceleration, you have to check where the graph is the steepest. So you can clearly see that this part of the journey has the steepest gradient, right? So all you have to do is just find out the gradient of this section of the graph. And gradient, as we all know, is change in y-axis by change in x-axis. So this is 1.2468. This is 1.8, and this value is between 4 and 6, that makes it 5. So acceleration is change in y-axis by change in x-axis. So A would be change in y-axis is 5 minus 1.8 divided by, now let's focus on the change in x-axis. This is 0 and 10, 5, 4. And this value would be, this is 15, so this is 16. So 16 minus 4. So this should get you, so the value is 0.27 rounded off to 2SF. 0.27, and since it's acceleration, the unit should be meter per second squared. For 13, the question says in a game of basketball, points are scored by throwing a ball so that it falls through a hoop. Fine. The rules state that the distance d between the hoop and the floor should be 3 meters. A basketball player throws the ball so that it falls through the hoop as shown. Fine. The ball was thrown from a height of 1.7 meter above the floor. Okay. The initial vertical component of the velocity of the ball was 5.1. So I have a suggestion. The moment you come across questions like these, always mark on the diagram. This will really help you a lot. So the initial vertical component of the velocity is 5.1. So just mark this with an upward arrow, and the value is 5.1 meter per second. Fine. As the ball entered the hoop, the vertical component of the velocity of the ball was 2.1 over here. So over here, the vertical velocity was 2.1 meter per second. And for this part of the motion, you can think of this as the initial velocity and this one as the final velocity. Now, what does the question say? Also, add all the information they have given in the question to your diagram. This will really help you a lot to visualize the whole scenario. For instance, the ball was thrown from a height of 1.7 meter above the floor. So this was 1.7 meter, 1.7 meter, right? So what does the question say? Deduce whether D was 3 meter. Okay. So this was a very clear case of equations of motion, right? So all you have to do is just consider this as your final velocity and this as your initial velocity. And then you have to find out the displacement, the vertical displacement, right? And with the vertical displacement, let's call that S, you add up this height And if the addition is equal to 3 meter, then of course D was 3 meter and it satisfies. So this is what you have to find out. The very first thing you have to do is find out this S. So you have this final velocity V, you have this initial velocity U. So you can recall the equation V squared equals U squared plus twice AS. So V would be 2.1 squared equals U would be 5.1 squared plus 2 times acceleration, since it's double motion. And you know in double motion the acceleration is minus 9.81 times S. Therefore S equals 1.1 meter. Now what you have to do is just add up this S with 1.7. So 1.1 plus 1.7 gives you 1.1 plus 1.7 gives you 2.8. 2.8 meter, of course. And I had to check whether this was 3 meter. So 2.8 meter is not equal to 3 meter. This is your answer. So if you look at this question one more time, you'll see the whole thing becomes very evident. The structure, of course, if you just add to the diagram. So this would be my number one suggestion. If there is a diagram, add to the diagram. If there is not a diagram, draw your own diagram. Now let's move on to question 14. The brakes in a car reduce the kinetic energy of the car. In an electric car, some of the energy is transferred to the battery in the car. An electric car of mass 1800 kg moves at a speed of 14 meter per second up a hill as shown. Fine. The driver applies the brakes to bring the car to stop. Alright. During the braking, the vertical displacement of the car is 0.76 meter and the energy stored in the battery increases by 45 kilojoule. Calculate the efficiency of using the brakes to charge the battery. So I want to teach you a technique that I promise you will come in handy during your exam. This is a crazy, crazy, crazy important technique that you can apply and ensure a decent grade. That is what I call modular approach. So when you read this question, I know how our students' mindsets work. So it's very hard to relate to the question. So if you adhere to the modular approach, you can salvage several marks from a seemingly completely unrelatable question like this one. So for example, you can clearly see this car has a mass and a velocity. So the very first thing that should pop up in your head if you follow the modular approach is kinetic energy. So let's first find out the kinetic energy equals half mv squared, right? So the mass is 1800 times v is 14. Don't forget to square, and the value that you get for kinetic energy is 176,400 joule. Fine. And like I say, always follow the modular approach. The car rises to a vertical height of 0.76 meter, right? So this is 0.76 meter, and you can also find out the gravitational potential energy of the car after it has reached this point, right? So E grav, actually change in E grav is mgh, which is mass is 1800, g is 9.81, h would be 0.76, and this gets you And the value is 13420. 13420 joule. So the change in energy, how much energy has changed, how much energy has been transferred. So instead of change, the more appropriate term should be energy transferred is 176400 minus 13420. So the value is 162980. I'm hoping that you are doing the calculations along with me. You should have a calculator in your hand. 162980. 162980 joule. Right, so the energy transferred is not entirely transferred to the battery. Okay, so only 45 kilojoule is transferred to the battery. And the question asks you about the efficiency. So efficiency is out of this energy the battery gets 45 kilojoule or 45,000. So this is the useful output for the battery, that is 45,000 divided by, and how much energy was given to the battery? This. So this is 162,980. This was available, and out of this energy, the battery got only 45 kilojoule. So the efficiency should be 0.28. And of course, efficiency does not have a unit. So for question 15, it says, a builder uses bricks to build a wall. As the wall gets taller, the force on the brick at the bottom of the wall increases. Of course, this is compressive force. The force compression graph for this brick is shown. Determine the increase in elastic strain energy in the brick as the force increases from 85 to 140 Newton. So the very first thing you have to find out is look at the compression or find out the compression when it's 85. So let's see. So 5 squares make 10. So every square, 5 squares make 50. So every square should be 10. So 10, 20, 30, 40, 50, 60, 70, 80. This is 90 and this should be 85. So 85 corresponds to this value. And yes, that's how specific you'll have to be, right? So 10 squares represent 50, so one square should represent 5. So this is 55, this should be 60. Okay, and the next value is 140. So this is 140, and 140 should correspond, that's not exactly 95. The value is between 95 and 100, so that is 97.5. And again, that's how specific you'll have to be. This is 97.5, right? So basically, you'll have to find out this area because this is the increase in elastic strain energy, right? And there is one way of doing this very simply, and that is find out the energy stored when the force is 140 and subtract it from the energy stored when it was 85 Newton, right? So you have to find out two elastic strain energies and just subtract them, right? So let's first find out the elastic strain energy when the force is 140, okay? And you all know the equation for elastic strain energy is half Fx. So it's half F is 140 times x, as in x could be compression as well as extension. So here we're dealing with compression. So 140 corresponds to 97.5. Oh, be very wary of these units. It's 97.5 times 10 to the power minus 9. It's in nanometer. And then you have the energy that corresponds to 85. 85 Newton, which is half F as in 85 times X would be 60 times 10 to the power again minus 9. So you need to focus on this one, the increase in elastic strain energy. So that is del E. This energy minus this energy would give you the difference in energies, which is equal to the increased elastic strain energy. Put in the values in your calculator and match with mine. So when you put the values in your calculator, it should be rounded off to 2SF. It's 4.3 times 10 to the power minus 6. So it's 4.3 times 10 to the power minus 6. Unit should be joule. Part B of the question says, the brick adds to the original shape when the force on it is removed. So here we're dealing with the brick. So the brick returns to its original shape when the force on it is removed. Question 16 says, a student used a falling ball method to determine the viscosity of vegetable oil. He measured the diameter of a ball bearing. He dropped the ball bearing into a measuring cylinder containing vegetable oil, as shown. The ball bearing reached terminal velocity. Important point to note that it had reached terminal velocity, meaning forces on it were balanced. The student then measured the time taken for the ball bearing to fall 20 centimeter. Fine. Student measures the time taken. Okay. And I know the distance. So distance divided by this time will give you this terminal velocity. Fine. Give one other measurement needed to determine the viscosity of the oil. So this is the falling ball method, right? And when the ball bearing is falling, these are the forces acting on it. One is weight, and since it has reached terminal velocity, the weight should be equal to upthrust plus drag, right? So for upthrust, you need the density of the fluid, right? And for weight, you need the mass. For viscosity, viscosity is inside this drag, everybody, right? Because drag equals 6 pi eta RV, right? Using Stokes law, of course. So to find out drag, you need the upthrust as well as the weight. And for weight, you need the mass. So the other measurement would be mass. And had this been more mark questions, had this been, let's say, 2 marks, you could have also said the density of the oil. The next part of the question says, the diameter of the ball bearing was 1.24 millimeter. The time taken to fall 20 centimeter was 1.3 seconds. The student calculated a value of 5.6 times 10 to the power minus 5 Newton for the viscous drag on the ball bearing. Calculate the viscosity of the oil. Now, I want to teach you all my secret. And whenever you come across a question of 3 marks or above, I want you all to apply this method for calculation questions, of course. And I call this method the modular method. And in that modular method, what you do is you just get started with the information given to you. For example, you know the distance and you know the time. So the very first thing that should pop up in your head is the equation speed equals distance by time, right? So distance is 20 centimeter. Of course, you have to convert this centimeter to meter, divided by 100, 0.2 divided by time is 1.3, which gives you 0.2 divided by 1.3. The value is 0.154, rounded off to 3SF because this is not my final answer. 0.154, and unit is meter per second. And then the student calculated the value of 5.6 times 10 to the power minus 5 Newton for the viscous drag. Okay, for the viscous drag. And since it's a spherical object moving with a constant velocity, you can apply Stokes law, right? So Stokes law is equal to the drag force. Stokes law force is equal to the drag force, which is F equals 6 pi eta RV. All right. So the value of F is given over here, 5.6 times 10 to the power minus 5 equals 6 pi. This is what you have to make the subject of the equation, eta, and the diameter is given 1.24. So you have to find out the radius. 1.24 divided by 2 gives you the radius divided by 1000, which is 6.2 times 10 to the power minus 4, and you just calculated this v. That's 0.154. So make eta the subject of the equation, and eta is the symbol for viscosity, by the way. And let's see what comes up. So I need you all to take your calculator and do the calculations with me. This is also part of your preparation. So the value that I get is 0.031. This is my final answer, which I can round it off to 2SF. 0.031. And always remember, they have given you the unit here, but the unit of viscosity is always Pascal seconds. Always remember this. The next part of the question says, the student repeated the experiment. He used the same oil at a lower temperature. Always remember, whenever you come across the concept of lower temperature or higher temperature in unit 1, always link it with viscosity. And I hope you all remember, lower the temperature, greater the viscosity. So the very first point should be, at lower temperature, viscosity is greater. Right? So if the viscosity is greater, viscosity is the stickiness, right? So it resists the motion of the object falling through it. So this reduces the terminal velocity, right? And if the velocity is smaller, it should take a longer time. So the third point is time taken is greater. Question 17 says, a violin is a musical instrument that has 4 strings as shown. The force extension graph for a sample of one of the strings is shown below. Fine. What does the question say? The table shows the stiffness for samples of 3 strings on the violin. Each sample was the same original length as the sample used to obtain the graph. Fine. Deduce which string was used to obtain the force extension graph. So all you have to do is just from this force extension graph calculate the gradient, and the gradient of force extension graph gives you the stiffness, and you find out the gradient from here, you get the stiffness, and you match with the stiffness from this table, right? Let's get started. Always remember, when you are finding out the gradient, always use a large triangle. This is imperative, everybody. This is very important that you always use a large triangle. So, and I like to take exact values. For example, I like this value, which does give me somewhat of a large triangle, right? So this value is 60, between 60 and 80. So this should be exactly 70. and let's find out what this value is. This is 20, this is 30, this should be 25, and every square gives you 1, so this is 26. And always be very careful about the units. This is 26 but millimeter. So the stiffness, which is K, is equal to change in y-axis by change in x-axis, which is basically the gradient of the graph. So change in y-axis is 70 divided by change in x-axis is 26 times 10 to the power minus 3, which gives you, so the value I got is 2692. 2692 rounded off to 2SF is 2700. Now let's look at the graph, not graph, the table. 2700 corresponds to Y. So the string that was used was Y, of course. So part B says the fourth string on the violin has an original length of 0.750 meter. When the tension applied to the string is 36 Newton, the new length of the string is 0.752. So this is the new length, this is the original length. Like I say, every time you get a question of 3 marks and above, apply the modular approach. So you have the new length, you have the original length. So the very first thing you should do is find out the extension. So extension del x equals 0.752 minus 0.750. So that should be 0.002. Unit should be meter, of course. Then they gave the radius, okay, and using the radius, you can easily find out the cross-sectional area. So area equals pi r squared, right? So using this value, I can find out the area. And always remember, since this is not my final answer, I'm talking about the area, since this is not my final answer, you cannot round it off to 2SF. It has to be at least 3SF. So it's 2.27 times 10 to the power minus 6 meter squared. So now I have the area as well, the extension. Now the question asks you to calculate the Young modulus. Recall the equation for Young modulus. Young modulus equals to stress by strain. You break them up. Stress means force per unit area divided by strain means extension by original length. So F by A times this gets inverted. So L by del X. Now all you have to do is just substitute the values into this equation. So E equals F. You know the value of F is 36. So 36 divided by area you just found out, 2.27 times 10 to the power minus 6 times original length is 0.750 divided by the extension. The very first thing that you had found out was 0.002. Again, my request to all of you, take your calculator, put in the values, and match with my answer. So the value I get is 5.95. So if you want to round it off to 2SF, it should be 6.0 times 10 to the power 9. And you know it's Pascal, right? And 10 to the power 9 basically means giga. So the value is 6.0 gigapascal. There is no need to give your answer in gigapascal. I just matched with the mark scheme. That's the only reason I gave giga. If you just leave it at 10 to the power 9, you still get full marks. Question 18 says, a Newton's cradle has 5 identical steel spheres, A, B, C, D, and E. Each sphere hangs on a string from a frame as shown. Fine. Each sphere has a radius of 7 times 10 to the power minus 3 meter. Calculate the mass of one sphere. They gave the density. Okay. So since it's a 3-mark question, like I've been saying from literally the beginning of this paper, is whenever you get a question of 3 marks and above, apply the modular approach and let's just get started with whatever information you have available. For example, you see radius and of a sphere, of course. So using the radius of a sphere, you can find out the volume, right? So volume should be 4 by 3 by r cube. So I have r and the volume is 1.44 times 10 to the power minus 6 meter cube. Then the question has the density given. And now you just link and recall the equation that links density with volume. Density equals mass by volume. So mass would be equal to density times volume. So mass should be equal to density times volume. I have the volume. Just multiply this with the density. So the value of mass that you get by multiplying density and volume is 0.011. 0.011. Of course, the value is in kg, but I just checked in the mark scheme. They have given the value in standard form. So 1.1 times 10 to the power minus 2. If you don't give it that way, you still get full marks. Absolutely nothing to worry about. Question B, it says the student pulls sphere A, so the string is at an angle of 38 degree to the vertical as shown. Fine. Determine the initial acceleration of the sphere A when released. So if this is the direction of acceleration, this is tension, right? So this is perpendicular. So tension will have absolutely no effect on the acceleration. So what do you think causes the acceleration? It's a component of the weight. So weight acts vertically downward. And let's recall our alternate angles. If this is 38, this should be 38. And this should be 38. So the weight is mg. Now mg has two components. One is with the angle, which is mg cos 38, and one is along this direction, that should be mg sine 38. And guess what? This component of the weight causes acceleration. So mg sine 38 is equal to the resultant force, which is ma. M and M gets cancelled out. Therefore, A should be equal to G sine 38. So let's see. G as in 9.81 times sine 38 gives you 6.0 meter per second squared. 6.0 meter per second squared. Now I have another suggestion for all of you. And that is when you're solving questions like this, if there is a diagram, always add to the diagram. If they don't give a diagram, draw the diagram yourself. I repeat, if there is a diagram, add to the diagram, and if there is no diagram, just draw the diagram yourself. This will come in handy in a lot of very tricky situations. The diagram 1 shows the position of the spheres when sphere A is released. After being released, sphere A collides with sphere B and comes to rest. Sphere B, C, and D remain at rest. Sphere E moves away from sphere D. Diagram 2 shows the position of the spheres when sphere E reaches the highest point. Describe the changes in energy and momentum of sphere A and E from the time sphere A is released until sphere E reaches the highest point. Ignore the effects of air resistance. So now let's look at the marking points. So the question clearly asks you to talk about energy and momentum, right? So as A falls, the gravitational potential energy of A decreases and the kinetic energy of A increases. Of course, A loses gravitational potential energy as the height decreases, and this gravitational potential energy is transferred to the kinetic energy. As A falls, the momentum increases because P equals mv. As velocity, as in kinetic energy, increases, the momentum also increases. Now, during the collision, momentum of A decreases and momentum of E increases. During the collision, total energy of A is transferred to E because A comes to rest, so all of its energy is transferred to E. And as E moves, both the kinetic energy and momentum of E decreases to zero because it comes to rest at the highest point. Okay, so when it comes to rest, its kinetic energy decreases to zero and the momentum also decreases to zero. And the gravitational potential energy increases to a maximum because it has reached its highest point. The question clearly spoke about highest point. The next question, that is 19, says a student stores her bicycle on a rack. The bicycle rests on a rail that can rotate about a pivot. This is the pivot. Check this out. To take the bicycle off the rack, the student uses a handle to lower one of the ends of the rail to the ground. A piston applies a force to the rail as the rail is lowered to the ground. So this is the piston that applies the force. Fine. The diagram shows the bicycle on the rack before and after the rail has been lowered to the ground. Fine. When the rail is in equilibrium, I want you all to focus on this specific word, equilibrium. The principle of moments applies. State what is meant by principle of moments. So when a body is in equilibrium, total clockwise moment is always equal to total anti-clockwise moment. So total clockwise moment is equal to total anti-clockwise moment. So for 1 mark answer, this is just fine. And if they had not mentioned this word, then this should have been another marking point when a body is in equilibrium. Question B says, after taking the bicycle off the rack, the student lifts the rail back to its original position. The uniform rail has a length of, okay, so this part is important. It is uniform, meaning the weight acts through the center of gravity, and the center of gravity lies in the geometric center. Has a length of 1.4 and a weight of 95. Fine. The student applies a force of F to the handle perpendicular to the rail. The piston applies a force of 160 Newton to the rail. The diagram shows these forces acting on the rail. Fine. Determine the minimum value of F needed to lift the end of the rail off the ground. Okay, so this is where the technique that I've been saying will come in handy. When there is a diagram, especially when it's a moment question, always make sure you add to the diagram. And what exactly do you add? You draw the forces that is perpendicular to the distance from the pivot. For example, this force is not perpendicular to this distance. So you find out the component of the force that is perpendicular to this distance from the pivot, right? So this is 160 and there is no angle here. So this is 160 sine 18 without angle is sine theta. Then I think you know this from your M1 mechanics that if this angle is 42, this angle should also be 42. So the component of weight in this direction is 95 cos 42. 95 cos 42, right? And when you mark the forces, don't forget to mark the distances as well. So mark this distance as well because This is a uniform rail and the whole length is 1.4. So half of it should be 0.7, right? So 0.7 meter. Once you have done this, then all you do is just apply the principle of moment. Total clockwise moment equals total anti-clockwise moment. So you can clearly see from here that the weight, as in the component of weight, is providing the clockwise moment, and this component of force, component of 160, and this F is providing the anti-clockwise moment. So just apply total clockwise moment equals total anti-clockwise moment. So for the clockwise moment is 95 cos 42 times this distance 0.7 equals, now bring in the anti-clockwise moments, which is 160 sine 18 times, always remember, it's for the moment it's force times perpendicular distance from the pivot times 0.37 plus you have this force times this distance from the pivot, and this is the entire length of the rail, which is 1.4. All you do is just make F the subject of the equation and you should get your answer. Do this and match with me. The value I got in 2SF is 22 Newton, and I did check with the mark scheme. This is indeed the correct answer. For the next part of the question, it says the student could have lifted the rail by applying a vertical upward force to the handle. Okay. The force needed to lift the rail is different when the force is vertical compared to when the force is perpendicular. You always want the perpendicular force, right? Because when it's perpendicular, there is no component. But when it is not perpendicular, only a component of that force provides the moment, right? So let's see the marking points. In either case, if you have to lift it, total clockwise moment is equal to total anti-clockwise moment. So each force applied by the student must cause the same moment about the pivot if you have to lift it, right? So when the force is vertical, perpendicular distance is less. So moment remaining same, just recall the equation for moment. Moment equals to force times perpendicular distance. If the perpendicular distance is now less, guess what? The force required will be greater, according to moment equals force times perpendicular distance. Now let's move on to the very last question. Question 20 says, a skydiver jumped from an aeroplane. The initial vertical velocity of the skydiver was 0. During the first 1.5 seconds, the skydiver moved a vertical distance of 11 meters. Okay, and one more important piece of information was initial vertical velocity was 0. Fine. Air resistance may be considered negligible if the mean acceleration of the skydiver is greater than 0.95 g. Okay. Deduce whether air resistance acting on the skydiver was negligible during the first 1.5 seconds. Okay. So if the initial velocity is 0, just recall the equation. S equals, the full equation was ut plus half at square. So if the initial vertical velocity is 0, so the whole ut becomes 0. So the equation gets reduced to S equals half at square, right? So A should be equal to twice S by t square. Let's find out A, everybody. A should be twice times S is 11 divided by T is 1.5, the whole value squared, which gets you So the value is 9.7777. So it's fine. You just round it off to 3SF, which is 9.78. 9.78 squared. Fine. Now, what do I have to do? Air resistance may be considered negligible if the mean acceleration is greater than 0.95 g. So this might be a bit complicated, but just bear with me. What you have to do is you have to check what percentage of g is this value. So all you do is just divide this value with g, the value of g, of course. So 9.78 divided by 9.81, which is equal to 9.78 divided by 9.81 gets you 0.997. 0.997, right? So this is 0.997 G actually. And the question says if it is greater than 0.95 G, then air resistance can be assumed to be negligible. But since this value is much greater than 0.95, which is 0.997 G, which is greater than 0.95 G, air resistance can be negligible. Part B of the question says the displacement time graph for the skydiver between the jumping from the aeroplane and opening the parachute is shown. So they have just, I don't know why, twisted this concept because you know this graph. This is a very basic displacement time graph. But what they have done for this specific question is they have somewhat considered displacement to be negative and time they have given upwards, right? So this was the actual graph that you are accustomed to, okay? And it's the same thing. Instead of positive values of displacement, they have taken the negative values of displacement as the parachute is false. Okay, time is the same. And instead of giving time downward, they have given time upward. That's the only difference. And the concept remains the same as well. So sketch a velocity time graph for the axis on the axis below for the skydiver between jumping from the aeroplane and opening the parachute. So you know literally from your IGCSEs a corresponding velocity time graph for this displacement time graph would be like this, right? Eventually it reaches terminal velocity. But since the displacements are negative, you know the gradient of displacement time graph gives you the velocity. So this will give you a negative value of velocity, right? So it's the exact same shape, but instead of drawing this in the positive axis, you draw the same thing, but in the negative axis, like this. Second last part of the graph. I mean, the question says, after jumping from the aeroplane, the skydiver accelerated and then reached the terminal velocity before opening the parachute. Explain how energy conservation applies to the skydiver before opening his parachute. Okay, so as the skydiver accelerates, his velocity increases. And you know, as the velocity increases, the kinetic energy should also increase. But as he falls, the gravitational potential energy decreases all the way through. And like I just said, while accelerating, the kinetic energy increases. Now, the decrease in gravitational potential energy is not equal to the increase in kinetic energy. The kinetic energy, increase in kinetic energy is a bit less, actually much less. So where does the rest of the energy go? Because energy is dissipated due to work done against air resistance. Now, when the skydiver reaches terminal velocity, kinetic energy becomes constant and all of the gravitational potential energy that is decreasing is dissipated due to work done against air resistance. Kinetic energy does not increase anymore the moment the skydiver reaches terminal velocity. Now let's look at the very last question. The skydiver opens his parachute and his speed changes. After a time, he reached terminal velocity. This is the lower second terminal velocity after opening the parachute. Explain how forces on the skydiver causes his acceleration to vary after his parachute open. Guys, I think this is one of the easiest questions ever because you have been seeing this literally since your IGCSEs. So what happens is the moment the skydiver opens the parachute, the surface area drastically increases. So the air resistance not only increases, it becomes greater than the weight. So when the parachute opens, the air resistance is greater than the weight. Now, there is a resultant force upward, but the motion was downward. So always remember, when there is a resultant force in the opposite direction to the motion, the body always decelerates. So as the skydiver decelerates, the speed decreases, and you should also remember that air resistance not only depends on surface area, it also depends on speed. So as the skydiver decelerates, the speed decreases, and guess what? The air resistance also decreases. So initially it was greater than weight, now it starts decreasing, and eventually air resistance becomes equal to the weight. Now there is no resultant force, and the acceleration also becomes zero. Thanks for watching. I hope you found this immensely useful. Please leave a comment and let me know, since you have already paid for this, let me know if there are any avenues I can improve this on. It took me 3 days to complete recording. I hope this was worthwhile. Thanks for watching once again.